Okay, so the title of these notes are going to be Properties of Logs. Properties of logs. Okay. And before we go too deep into the properties of logs, before we get started with the properties of logs, I just want to remind you of our warm-up that we did on Friday, which was looking at some of our exponential rules. Tyler, put the phone away. So if we have x to the second times x to the fifth, x to the second times x to the fifth, what is that? X to the seventh. So if you are multiplying two terms together and you have the same base, then you just add your exponents, right? We remember that? Okay. What if we had x to the eighth over x to the fifth? X to the third, you would just subtract. So if you're dividing, you just subtract your bases, or subtract your exponents. You have the same base, and you're dividing, you just subtract your exponents, okay? Yeah.
Would it work if like the 8 and the 5 was switched?
Yeah. So let's say we had x to the fifth over x to the eighth. If we were to subtract them, we would get x to the negative third, or we could say 1 over x to the third, because negative exponents is the same as having an exponent on the bottom. So some people would subtract these and just say, I have a negative exponent, I'm okay with having a negative exponent. Other people would say 5 x's on the top can cancel with 5 exponents on the bottom, and it leaves exponents behind on the bottom. You get 3 left over. Yeah. Either way, you're still subtracting. Yeah, good question. Another way, another rule that we learned about is if we have x to the third raised to the second power, what would that give us? Yep, x to the sixth. And we get that because we multiplied the exponents, right? This would be x to the third times x to the third, and then 3 plus 3 is 6. X to the third squared, we multiply the exponents together. Okay, so, and then just a reminder, exponentials and logarithms are inverses of each other. And if they're inverses of each other, what does that mean? They're opposites, they're operations that undo each other, they cancel each other out, that sort of thing. Kind of like plus and minus, kind of like multiply and divide. They have a relationship. So we're going to notice when we work with logarithms, we're going to notice that like, oh, there's some things where like, if it's one situation with exponentials, then we're going to see there's something similar with logs that's kind of an opposite situation. That's what we're always going to notice. Okay, so I want you to grab your calculators, and we're going to look at some things here. Okay, we're going to find the decimal for log 12. So just hit the log button, log, and then type the number 12. So I'm hitting the log button right here, right here, and then I'm typing the number 12, log 12. Okay, 1.079. 1.079. Okay? Log 12. All right. Next, I want you to type log 6 plus log 2. Log 6 plus log 2. What do you get? Same thing. Okay, let's write that. Log 6 plus log 2 is 1.079. Okay, let's try log 3 plus log 4. Log 3 plus log 4. Log 3 plus log 4. Also the same thing. Let's try log 1 plus log 12. Surely that wouldn't be the same thing as just plain log 12. Log 1 plus log 12. Same thing. Okay, let's try another one. Let's try log 48. Okay, what is log 48? What is log 48? 1.681. Okay, so give me some numbers that I should use. We're going to do, what did you say? 24 and 2. We're going to do log 24, log 2. Okay. Log 24 plus log 2. 1.681. Okay. What about if I did log 6, log 4, log 2? Does this still multiply to 48? 6, 4, and 2? Yes? Okay, let's try it. Log 6, log 4, log 2. 1.681. Okay, so what I want you guys to notice, you guys have been chatting the whole time. Okay. So up here, if we multiplied things, the shortcut was to add. Okay? Down here, if we add things, the shortcut is we're multiplying. Do you guys see the relationship there? See how they're backwards? Okay? Up here, if we're multiplying, the shortcut is to add. Down here, if we're adding, the shortcut is we actually multiplied. Does that make sense? Okay. So if I wanted to see what log 7 plus log 9 plus log 3 was, and I only let you touch the log button one time, yeah, you would figure out what these all numbers were all multiplied together. So 7 times 9 is 63. What's 63 times 3?
189.
Okay. Is it 189?
Yeah.
189? So then that would be the same as log 189. And we can double check that, right? We can say log 7 plus log 9 plus log 3 is that decimal. 7 times 9 times 3 is 189, so log 189 is going to be the same decimal. 2.276, 2.276. Same thing. Does that make sense? So if you ever forget the shortcut in logs, because logs are not as natural to us as exponentials, you just say, what's the exponential rule? It's that when you multiply two exponents, you are actually adding them. So down here, when you are adding logs, that means you're actually multiplying. Does that make sense? Okay. So let's do a couple examples of this. So this is called, if we take something like log 189, or if we take something like log 48, and we write it as log 24 plus log 2, or we take log 48 and we write it as log 6 plus log 4 plus log 2, that's called expanding. If I take something that was simple, log 48, and I write it as separate logs, log 6 plus log 4 plus log 2, I'm expanding the log. Does that make sense? If I take something like this that is log 6 plus log 4 plus log 2, and I put it back to log 48, that's called condensing the log. Does that make sense? Putting it back together. Okay, so I want to show you guys a couple of what you could see if you're doing something that's in like variables as opposed to something written like this. So let's say that we were doing expand log x, y, z. Then I would just look at how many things were multiplied together. So I can see 3 things that are multiplied together. So what I'm going to do is I'm going to write the word log 3 times. Log for the x, log for the y, log for the z. And then because these are being multiplied, there's going to be a plus sign in between each of them. So I would say log x plus log y plus log z. That's how I expand that out. If I wanted to condense log base 2 of 2x plus log base 2 of 3y, I have the log written down twice, and I'm only going to be allowed to write it down once if I'm condensing. So for the condensing, I would say, all right, I wrote log base 2 twice. I'm going to write it down once. This has a plus in between. That means that these two things should be multiplied together. 2x multiplied by 3y is what? You can write 2x, 3y, or could you multiply the 2 and the 3? Yes, so it would be 6xy. Yeah. Okay. So for expanding, we just see how many things we have multiplied, and that's how many times we write the word log. For condensing, we only get to write the word log one time. Now, if this one had a log base 2 and this one had a log base 3, we wouldn't be able to combine them together because they'd be different terms. This is kind of like a combine like term sort of situation. They have to be the same term. Now, maybe in like upper level mathematics, they might deal with logs that are different terms, but I've literally never seen that. They're like always like terms because you're always dealing with a problem where you could actually solve it, which means you're always working with something you can actually condense. Okay, so let's look at another shortcut to see what we can come up with. Does this make sense? Are you kind of seeing how it might work? Okay, so we know now that if we see plus signs in between that we're going to be multiplying things together. So let's look at another thing that we could learn about logs. So here, let's type in log 5 and see what that decimal is. So log 5 is what? 0.699. Okay, what is log 10 minus log 2? Log 10 minus log 2. Okay, log 10 minus log 2 is the same thing. Okay, someone give me another one that you think would be the same thing. Log 25 minus log 5. Okay, let's see if that's the same thing. So log 25 minus log 5. Same thing. Someone give me another one. Log 50 minus log 10. Let's see. Log 50 minus log 10. Same thing. Okay, so what are we seeing from this? Yeah, division and subtraction have a relationship in logs just like they did in exponents. So in exponents, if you were dividing two terms, then you would subtract the exponents. Here, if you are subtracting logs, that means that you are actually dividing the numbers. So kind of the backwards version. If you're subtracting logs, that means that you're actually dividing the numbers. So if I'm writing something like so expand the log, let's say, we'll say ln x divided by yz. I'll write it like this. If we want to expand this, then I have 1, 2, 3 things written down. Do you guys see that? 3 things written down. So I'm going to write log, or I'm going to write ln in this case. I'm going to write it 3 times because I have 3 things written down. Does that make sense? Okay. So I'm going to say ln x to start. ln x. Now, these 2 things are both on the bottom of a fraction. So that means that they are both going to be minused. They are both on the bottom of a fraction, so they are both going to be minused. So I'm going to say minus ln y minus ln z. Okay? That is one way to correctly write this. So the minus tells you it's been divided. The other minus tells you that's also been divided. They're both on the bottom of the fraction. Okay, that's one way to write it. Another way to write it is to say ln x minus, and then you could put parentheses, and you could put a plus between these 2 things, because even though they're both on the bottom of the fraction, it is correct to think of them as being multiplied together, right? Y and z have been multiplied together. Does that make sense? So I could say ln y plus ln z, because the y and the z are being multiplied together. And then if you think about this, the algebra still works, right? If I was to distribute this negative, both of those terms would be negative because they're both on the bottom of the fraction. So either one of these would be the correct expanded version for this problem. They would both get full credit. In a multiple choice problem, you might see one or the other, but if you did this as a free response answer, both of these would be right. Does that make sense? So you could say minus in front of parentheses, and then you could say they're multiplied together, so I'll put them as a group. Or you could write them completely separately and say this one's on the top, and then minus for both of these because they're both on the bottom. Make sense? Okay. Let's try condensing one. Let's say condense log base 3 of 4x plus log base 3 of 6y minus log base 3 of 2z. Okay. So if I was to condense that, how many times am I going to write log base 3? One time. I'm going to write log base 3 one time. As soon as I see a minus sign in the problem, I'm going to give myself a little division symbol. Okay? And what goes on the top? 4x times 6y would be 24xy. Okay, 24xy. And then what goes on the bottom? 2z. Is there any simplifying to be done? Yes. So the 24 and the 2, what should I get? 12xy over z. Okay. Okay, let's try one more example. All right, log 16 is 1.204. Log 16 is 1.204. Okay? So I could take this and I could find log 16 by doing log 2 plus log 2 plus log 2 plus log 2. Right? Okay. So 1, oops. Two, 3, 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16, yes. Okay, so 1.204. Now, another way to write this same line would be to say that I have log 2, and how many times did I add that number together? 4 times. So I could say 4 multiplied by log 2. Would you agree with that? Yes. Okay. 4 multiplied by log 2, 1.204. Okay? Okay. Let's do this again. Let's say I had log 4 plus log 4. Would that also work to give me log 16? Yes, okay. Log 4 plus log 4, 1.204. Now, since I have the same thing twice in a row, I could shorthand this by saying what? 2 log 4, and I would also get 1.204. Okay? Let's say I had log 25. Yes? Yeah, I have some up here now. Somebody left them behind when I subbed. It's very nice of them. All right, log 25. How could I rewrite log 25? Log 5 plus log 5. How could I rewrite log 5 plus log 5? I could say I have 2 log 5s. Okay, and what do I get when I plug in any of those? 1.398 for all of those. Okay. Okay. So the other thing that we're learning is that when you have an exponent, so if you have 2 to the 4th, log 2, log 2, log 2, log 2, that in this case is just going to be repeated multiplication. Does that make sense? Repeated multiplication. Because if we go back to exponentials, when we multiply two exponents, we just add the exponents together, right? When we multiply two bases. So down here, if I did, let's say I did a problem like x to the third raised to the seventh power, if I wanted to write that out, I would have x to the third, x to the third, x to the third, x to the third. And do you guys see how this is becoming repeated addition? Yeah. So that's what this is saying over here, is that when I do this with logarithms, I'm having repeated addition. Does that make sense? So whenever I have an exponent, let me show you how this works. We are going to expand log x to the fourth. Anytime we have an exponent, we're going to show that it's repeated addition. So, and the way that we do it is you could write this as log x plus log x plus log x plus, log x. You could do that. Thankfully, this is not the common practice. So they could make you do it 4 times because that's what it truly means to say to the fourth power. It means that you are multiplying the same thing 4 times. Now, instead of doing that, they say, well, we know that you're going to be multiplying the same thing 4 times. Let's just say that you have 4 of the same thing. So what you end up doing is you skip this step and you just take your exponent and you just move it to the front. It's way easier than having to do that multiplication instead. So they just say, if you had x to the fourth, we would be turning it into an addition problem. Log of x, log of x, log of x, log of x. There would have been 4 of them, but instead of actually showing that work, let's just say, let's skip that work and let's just say we know there's 4 of them. Okay, now let's try one of the condensing problems. If we were to condense 3 log base 2 of y plus 7 log base 2 of z, the in-between step would be to say log base 2 of y plus log base 2 of y plus log base 2 of y, and to recognize that there are 3 of them there, and then to understand that if there are 3 of them there, what's happening? You have y times y times y, which is what? If you have y times y times y, y to the third. So, but instead of showing that work, you can just say, oh, let me take the 3, let me put it back as an exponent to the y. Instead of thinking z times z times z times z 7 times, let me take the 7 and just put it back to the z. So here, anytime I condense, I'm always going to write the word log 1 time. Y is to the 3rd power. Z is to the 7th power. I knew that these were being multiplied because there was a plus sign in between. Okay, how do your brains feel? Pretty good? Okay, so now we are going to tie those rules together and then try some more difficult problems, because of course they like to mix all the rules at the same time. So we're going to say the condensed versus expanded So the product rule is log of A times B. The expanded form is log A plus log B quotient would be log A divided by B log A minus log B So those are the 3 rules we just learned. Okay. So let's try ln u over v to the 6th. ln u over v to the 6th. So how many times am I going to write ln? Twice. There's 2 variables. I'm going to write it twice. Okay. So for the first one, I'm going to write the u. For the second one, I'm going to write the v. Because there's a division symbol, what am I going to have in the problem? I'm going to have a minus. Okay. So ln u minus ln v. Now the 6 is not going to show up as a 6 like this, right? Because we take an exponent of 6 and we always move it to the front when we're expanding. Okay? So I'm going to take that exponent of 6, stick it right here in the front. The alternative to that is to say minus ln v, minus ln v, minus ln v, minus ln v, and do that 6 times. And please don't do that. ln u minus 6 ln v. Okay, this one we're going to try log base 6 a to the 3rd times b. The whole thing is being raised to the 4th. Okay. How many times are we going to write the word log base 6? Twice. There's 2 variables, okay? Now, this exponent of 4, does it just go to the a, just to the b, or does it go to the whole thing? It goes to the whole thing, which means that the 4 is going to go in front of the whole thing. Does that make sense? Now, this is a multiplication problem, which means we're going to have a plus in between there. If the 4 goes to the whole thing, it's going to need to be in front of parentheses to show that it applies to everything, okay? So we're going to stick a 4 in the front, and then we're going to have parentheses to show that that exponent of 4 applies to everything that we're about to list, okay? So I'm going to have a log base 6 of what? A. Is it going to be a to the third? No. What do I do with the third? I move the third to the front of this part. An exponent of 3 has to move to the front. This is a multiplication problem, so now what do I write? Plus. Is it just a B? Log base 6 of B. So I wrote the twice. I made sure that none of my exponents looked like exponents. I brought them to the front. The alternative for this one would have been to write log base 6 of A plus log base 6 of A plus log base 6 of A, and then plus log base 6 of B. So that would have not been fun. So instead, I just said there's 3 of them. Okay. Okay. Let's try this. Log base 4 of uv squared times w to the 4th. How many times am I writing the word log base 4? 3 times. Once for u, once for v, once for w. Okay? Does the 2 go to the v or the u and the v? Just the v. What exponent does the u have? A 1, technically. Okay, so I'm going to write log base 4 of what? U, okay, plus 2 log base 4 of v. Okay. All right. Log base 9 of zx squared over y to the 3rd. How many times are we writing log base 9? 3 times. All right, I'm going to make you guys uncomfortable on purpose when we write this one. Okay, are you ready? All right. Log base 9, what should we write first? Z. Now I'm going to make you do the minus. Minus. It can't be 2 because that's on the top. So it has to be the 3. 3 log base 9 of y. So now how do we get back to the top again? We're going to write a plus. So if you're ever looking at things that are multiplied together on the top, you're just going to write pluses. If you're ever looking at things that are on the bottom, you're writing minuses. Anything that's got a minus in front of it is automatically on the bottom. Anything that's got a plus in front of it is automatically on the top, okay? Multiple minuses is going to be multiple things on the bottom, even if you've got pluses and minuses between different things, okay? So you can kind of think of minuses as placing things on the bottom and pluses as placing things on the top. And if there's more than one, it's going to force them to multiply together. Does that make sense? It's going to force them to multiply. Okay, so negative 3 log base 9 of y, and then what's the last one? 2 log base 9 of x. Okay. All right, let's do... Okay, this one's good. We're going to do log base 3 of z to the fifth times the third root of xy. How many times are we writing log base 3? We're going to write log base 3 3 times. Okay, so what should I write first? I'm going to start with the 5. 5 log base 3 z, okay, plus, yeah, what exponent is a third root? Not cubed. You're close. 1/3. It's an exponent of 1/3. And does the 1/3 apply to just the x or just the y? Both. And how many logs are we going to write for these? We're going to write 2 different logs. Okay, so I'm going to say plus 1/3. And what should I do now since I'm writing 2 different logs? So you've got 2 options here, but we got to make sure the 1/3 applies to 2 different logs. So you can either put parentheses and then only write the 1/3 this one time, or you can make sure to put the 1/3 in front of each of those 2 logs. Does that make sense? So 1/3, write it one time with parentheses, or write the 1/3 twice, once in front of each log. Okay? So 1/3, do you guys want to write it twice, or do you want to write it with parentheses? Parentheses? Okay, so we're going to say 1/3. This is going to apply to 2 different logs. So now we're writing log base 3 of x plus log base 3 of y. So that 1/3 exponent applied to 2 different pieces. All right, how do we feel? Feel pretty good? Okay, let's try some condensing problems. Okay, we're going to do log x minus 3 log y. Log x minus 3 log y. Okay, how many times do I get to write the word log? 1 time. Okay? Okay, it's got a minus sign, so what should my problem have? A division sign. What's on the top? What's on the bottom? Y to the third. Okay? Let's do... So we got log base 5 of x minus 2 log base 5 of y minus 3 log base 5 of z. So how many times can I write log base 5? 1 time. Okay. I've got minuses in the problem, so what should I draw? Division sign. Okay. What's on the top? X. What's on the bottom? Y squared. What else is on the bottom? Z cubed. Z to the third. Okay, this one's kind of weird. It is way easier than it looks. Somebody want to answer the phone for me? Anybody have an idea of what we could do? Say it again. So if we add all the way across, what is that? Multiply. What are we multiplying? X, Y, and Z. What's the twos on the bottom? They're common denominators. So let's think of ones where we wrote it ourselves so we kind of know what's going on. Are there any problems where we put a fraction in the problem?
Yes.
Number 5, we put a fraction in the problem. Could we have made that fraction as like a divide by 3? Like log base 3 of x over 3, log base 3 of y over 3? Okay, so is it possible that this problem is like our number 5, but they wrote it differently? Okay, so can we fix number 8 so it feels more like our number 5? Wait, is this a base though? Okay, so this is ln x. What number, if they were to not, if they didn't do it, because we could have written log base 3 of x, and we could have put it over 3, right, instead of having a 1/3 in front? So that means that this is ln x with a 1/2 in front. And that means that this is ln y with a 1/2 in front. That means that this is ln z with a 1/2 in front. Okay? Now, remember up here when we did number 5, we said we could do 1/3 in the front of the whole set of parentheses, or we said we could put a 1/3 in front of each term. Both of those would have been correct. Now, we chose not to put a 1/3 in front of each term. We chose to just let it be in front of the parentheses. What does it look like they did? They chose to put the 1/2 in front of each term, right? Okay. So if they put a 1/2 in front of each term, what does that mean? There's a power of 1/2. What's a power of 1/2? Not a -2. It's a square root. Okay. So there's a power of 1/2, which is a square root. And if it's in front of each of these, what does that mean? The square root is in front of everything. So really what this problem is saying is that they've got a 1/2 and it's in front of every single piece. This is how they could have written the problem, but they did not write it this way. Does that make sense? So they put the divide by 2, divide by 2, but divide by 2. This is just personal preference. It's how you choose to write it. So some people choose to put their coefficients that are fractions. They choose to not write them as fractions. They choose to write them, or not as coefficients really. Instead of writing them as coefficients, they put them underneath. And that's a personal preference thing. And then some people choose to do what we did and just write it with parentheses, and some people don't like parentheses, and so they write it under every single term. Do you guys see the difference? Okay, so let's go ahead and write it now. We're going to have ln. We just get to write it one time. We have x, y, z, right? X, y, z. All three of those have the same exponent, but it's not really an exponent. What is it actually? It's really a square root. So all three of those have a square root over them. So it's not as bad as it looked. We just had to understand what it was trying to say. Square root of x, y, z. Okay, let's do one last one. 3 log base 3 of x plus 5 log base 3 of z plus 6 log base 3 of y. So how many times do we get to write the word log base 3? One time. All right, and then what do we have? Z to the 5th, y to the 6th. Done. Okay. All right, so the worksheet that I handed back to you guys from Friday is actually what we're going to work on. So on Friday we did 1 through 18. Now today we're going to work on 19 through 36. You can do it today. You're fine. Yeah. All right, so we're working on the last of that worksheet, 19 through 36.